Hi my friends, today we'll discuss about welding. This is an assembly which needs to be welded, and the funnel will have this welded assembly which has some welds at the bottom, some welds here, and a cosmetic weld which doesn't add material to the assembly. The drawings are two. One is before welding, this one, and another is after welding. The assembly has 5 parts: a plate, a tube, a sleeve inside this, and 2 handles. I want to show you that we can apply preparation of the parts before the welding, and we also can apply machining after the welding. So we have 3 possibilities. One is preparation, another is welding, and the third is machining. We'll see how to make all this. Let's start with creating the components. Dimensions are here, so we can start. We start with the plate, and I'll go speedy to this part. You see, I create a circle, I extrude the circle on 10 millimeters, then I apply a cut by using the dimensions in the drawing, of course. 22 divided by 2 is the radius. Four cuts are there. Then I apply the material, which is steel cast, to both material and aspect. I create names for every of that 4 parts. One is in 2 instances, the handle. I create that parts with the names having the suffix after, and this is not after the wedding, but after we have created them, because the names plate and not plate after, for instance, were the names of the demonstration assembly at the beginning. You see, each one has the name after: sleeve after, handle after, plate after, and tube after. All of them will be used to create a new assembly, which is also called after, but this is not connected with the welding. This is before and after we create the components and the assembly. You see, the handle has a curved face. Now we create the assembly. The assembly is this one. We start with the standard millimeter IAM. Place. The first is the plate, but the plate after we created, not plate used as a demonstration at the beginning. Plate after. Placed, grounded at origin, escape, blank or space, because I want to repeat the place. Tube after, somewhere outside of the plate. Escape, space. Sleeve after, escape, space, and twice for the handle after. We apply constraint, insert bottom face with the plate, apply, then aligned for the sleeve inside the tube, then mate the axis on axis, apply, then axis on axis, apply. As you can see, these two are on the same axis with the tube. I place them on the same axis, this axis, to be aligned with this axis. Now we have the two very well placed inside or outside, but on the tube. I put them aligned with this plane, so I apply constraint, selecting that plane. This is the plane, and then I select the point. Yes. Okay. What do we have now? We have the handles placed aligned with the plane. The drawing shows us the distance. The distance is 190. Be careful, I added this 80 because it was mixed by me. Excuse me. So 190 from the bottom. I go to the new assembly, constrain this axis about this face at, I write here, yes, 19, and I see that this is going down. I don't want this. I go back here, home, minus, and now the dimension 190 is up. Good. F6. I like to see the edges, so I go to visual style and I select shaded with edges. Now we see edges. This is the assembly to be welded. Good. Since we have the intention to weld these parts, we go to environment, convert to Weldment, and we receive an important message. Once an assembly has been converted to a weldment, it cannot be converted back to an assembly. The BOM, bill of materials structure, will be set to inseparable. Edit the BOM if you need a different structure. Continue. Yes, I want this way to convert the assembly to a weldment. Yes. What material for weld bed you want? I want ISO and I want steel milled. Not aluminium, not alloy, steel milled, usual for carbon steel. The BOM structure is inseparable. You can select other options, but inseparable is our option now. Okay. Now we have the tools for welding. As I said, the most important are preparation, welds and machining. I want to chamfer this component, the tube, at the bottom with 7 millimeters. So I select preparation. You see that we now have an end of features here. So we create features between these two lines in the browser. What do you want to do? I want to create a chamfer. Which edge to be chamfered? This. 2 millimeters? Not 2 millimeters, but 7 millimeters. Okay. Now I have, as you can see, I have a part with the chamfer. You want to create some other preparation features? No, this one is all I want. Good. Then I go back and I select welds. I have now 3 options: fillet, groove and cosmetic. I select fillet. Why? Because I want to apply weld between this face and the handle. One selection is the first face. The other selection is the second face, but both of them can be more than one. One face, one component is number 1 set and it is selected, and the second one is this and this. So we have 2 faces for the second set of faces. Good. Now I place here my dimensions, 8 millimeters and also 8 millimeters. The other one, not 10, it was too larger. The first. And I want to create also symbols for my weldings, or welds. Create welding symbol. what are these. I place here 8, and this is enough for the fillet weld. That's all. Okay. You see, we have a symbol here, and we can use this symbol in the drawing when we create a drawing for the welded assembly. Good. Do you want to create another weld? Yes, sir. I want to create a weld at the bottom, but not continue, but intermittent. What kind? Fillet. Good. I still leave here 8, but the first face is this one. The second face is also only one face, this one. And now you see the future weld. I said that I want to be intermittent. I place here the length of each bed, 53, not 100 is the first, 53 is the second, and the number is 4. I want to have 4 weld bed. Length is 100 and spacing, the space is 53. Symbols, yes, I want to create symbols. I place here 8, also 8 here, then 4, 100 and 53. Okay. Next is the cosmetic weld, which is this one. You see, here is a special weld. To do this, we select cosmetic, the third option, and an edge, this one. But we want to create also welding symbol. The welding symbol has none up, but a symbol down. This is the symbol. The value is 6 chamfer, and another option is a simple line. Okay, we see that we have a new symbol and a new weld. We finished the weldings, and now we go to machining, the third stage. Machining is this 45 hole, nothing else, but the hole is through all the part. To do this, we use the tool hole by selecting this face, concentricity, the diameter of 45, it is already selected, and through all. Okay, you see now we have a machined feature. Again, this is another section. You see there are 3 sections: preparation with a chamfer, welds with 3 welds, and the new machining. That's all. Return. And now if we want to see the parts and we double click any one of them, like this one, we see that it has no chamfer and no machining. Yes? What means this? This means that we altered the part, we modified the part, the assembly, not the part, by using this preparation and machining tools, but they don't affect the components. This is a unique object with these characteristics: welding, preparation, machining, but the parts are the same. For you, I save this as a welded assembly after. Save, and now I can open each after part. For instance, handle after, which has no hole inside. Yes, it is part of this assembly, the last one, but it has no holes. You can use the parts to make some other assembly, but this assembly, open the welded assembly after, is as you see with all that characteristics. We can use now this tool to obtain the material which was consumed. I already saved this. I'll place here again after save. Having this, we can open the Windows File Explorer and double click on the new weld bed report to see data. As you can see, the name of the assembly: fillet weld 1, fillet weld 2. The first is simple, the second has some interruptions, and the cosmetic weld, which has no apport, no mass of the material. You can make calculus here. For instance, you can place here the sum of the meshes. Oh, I made a mistake. Sum of the two. And now we have, you know, we can have a lot of welding, and we have the mass of the necessary material for creating the weldment. You can find the volume and so on. Good. Save, back,